Okay, so we're moving on to the next unit, and the next unit is algebra and everything to do with algebra. So the goals for this unit are simplifying algebraic expressions, adding and subtracting polynomial expressions, solving linear equations, and then to use algebra to solve word problems. So today, section 2.1 is what we're going to call it. And what we're looking at for our goal is I can recognize like terms and I can simplify by using the distributive law. So a few new things there maybe for you, like terms and the distributive law. Now, the first thing that we're going to look at is terminology. Okay, so you have terminology and notation. Notation is just a fancy word for how do I write something down. So when I look at this here, 3x squared y, what's happening here is a couple different things. The x squared y is actually just, sorry, here are variables. Okay, so variables means they are letters that are standing in for numbers. Okay, the reason they're variable is they can change depending on the type of question we're dealing with. Okay, the next part that we're looking at is the number 3. The number 3 is actually a coefficient, so fancy name coefficient. So it tells me there are 3 variables, 3x squared y's. Okay, and what we also know is we call these a term. As soon as I find it here somewhere, there it is up here, I think somewhere. I'm sure this is the part that you find really funny. It's the teacher trying to find the stuff that's hidden somewhere. There it is. Knew it was somewhere. So it's called a term. And this term, this 3x squared y, is held together through multiplication. So it really says 3 times x squared times y. Now there isn't any multiplication sign in, and that's a couple different reasons why we don't put it in. Is a multiplication sign could look like the variable x. So if there is no signs in between variables, it means they're being held together through multiplication. So let's talk about what a like term is. So I told you this is a term, all this together, but what makes something like or not? So first of all, like terms share the exact same variables, and each of those variables must have the exact same exponent. Okay, so let's take a look at an example by what they mean by that. So first of all, it says, this example says, group the following like terms. Now, so according to this, it has to have the same variable raised to the same exponent, to the same power. So for instance, if I take this 5x squared, if I want a like term to it, it also has to have an x to the power of 2. Well, here's one with an x, but it's not to the power of a 2, so that doesn't go. So, oh, here's one here. So 4x squared. Okay, yes, they have different coefficients. This one has a 5, this one has a 4, but that's fine. The definition, exact same variable to the same power. So let's take this 5x. Do I have another term that has x to the power of 1? Notice we don't see the power of 1 here, but it is there. So we go through and again we try to find, well, here's a negative x, 8x. Okay, so that one's going to work as well because different coefficient, but it's the same variable to the power of 1. And again, if we look for some more, here's another one of 4x. Now what I'm going to do is I'm going to just try to do it this way. So negative 8. Well, it doesn't have a variable. It's a constant number, negative 8. So all constants are like terms as well. So if I can find something else that's just a number, it belongs together. Okay, so those are like terms. Now if I take a 4y squared, so what I'm looking for is another term that has just a y squared. And you can see it's here. Now let's take a look at the last ones. Okay, here's a 5xy. So I'm looking for something that has an x to the power of 1 and a y to the power of 1. The coefficients don't matter. Oh, here's one here. Then I look at this last one. Where does it go, or is it by itself? At first you might think, oh, it's by itself. But let's take a look at what a like term is. It's the same variable to the same power. So this one actually belongs with the 5xy and the negative 8xy. The reason being, same variables, both to the power of 1, just like the 5 and the negative x1 are. So we're going to talk about another question dealing something with this, and this is how it goes. Explain why 5xyz, 8yzx, and negative 12yzx are like terms. So I'm telling you they're like terms, okay? And the reason they're like terms is because, a couple different things, when multiplying, the order of the variables do not matter. Now, the reason they don't matter is because, remember, those variables are like numbers. So if I take some things that I know that are like numbers, such as 5 times 3 times 2, 3 times 2 times 5, 2 times 3 times 5. So there's three terms there being multiplied together. And notice order doesn't matter. When I multiply all those together, they all equal 30. So order of variables do not matter because order of multiplication does not matter when everything's just being multiplied. All right, so now let's talk about what we call still like terms, but what we're going to do is we're going to simplify. Simplify means a few different things. Number one, it's not going to say x equals a number. Notice there is no equal sign on my beginning question. So all I'm doing when I'm simplifying is I'm putting like terms together. So in fact, what I'm doing is I'm finding like terms and adding their coefficients. So finding like terms and adding or subtracting their coefficients. So let's take a look first of all. Now, often what I do when I'm doing these is I actually take and I underline things that go together. Okay, here's a 2x. Is there another term that is like to 2x? So I'm after terms that have the variable x raised to the power of 1. Well, obviously this one's not. This one is, and I'm going to take the positive sign that's in there. And you're saying, you said positive sign. It says plus. Plus and positive mean the same thing. Then if I look at this next one, it is also x to the power of 1, so it also belongs to this. So I have two x's, a positive 7x, and a negative 9x. So really what I'm doing, and depending on how well you are with this, and I'm just going to bring up the calculator to show you that all I'm doing is I'm going a positive 2 plus a 7 minus a 9. And when I hit enter here, that's going to tell me how many x's I have. It says I have 0 x's. Amazing. So when I do that, I have 0 x's, and so I'm going to literally put down equals underneath 0x. And now I go and look to see what other terms go together. We can see the only other thing I have here is a plus 5y. There's nothing else there that goes with it, so it's a plus 5y. Now, I'm not going to leave it in this form because I'm just have 0 x's. So what I'm going to do is I'm just going to put a 5y. That's my final answer. Okay. Let's look a little closer, examine this question. First of all, after I have underlined everything, now I use different colors. You can, or you can use one line belongs for certain kind of like variables and two lines underneath is another. If I have taken the sign that goes with each variable, when I go back and look, everything in that line should be underlined, and it is. Okay. Other thing, notice I have an equal sign directly below. I have only one equal sign per line. So if I do any rough work, I'm going to do the rough work to the side because one line to the next line to the next line, it means everything here is equal to each other. So this 5y equals this line. The 0x plus 5y also equals that line. Okay, so everything directly underneath, it's assumed that it is equal. All right, so let's do another one. I'm not sure if I left us enough room for this one. I'm just going to move mine up a tiny bit. Okay, this time what's different is I have lots more terms. Not that it's any harder. So let's start by looking at the x squareds. So I'm looking for terms that have x squared. There's an x, here's an x squared. So directly underneath, I have a negative 5 and a positive 6. Negative 5 and a positive 6 is a 1x squared. Again, I'm not putting the 1 there. I don't need to. Then I go and look next. I'm going to do all the ones that have variables first. I have a 2x. Do I have any more x's? Oh, at the end here. So I have a positive 2 and a negative 10. Positive 2 and negative 10 is a negative 8x. And I'm now left with my constant terms. I have a negative 3 and a positive 10, which would give me a positive 7. So this question is now finished. I look here, I've underlined, circled everything, so I haven't missed anything. And none of these terms here belong together. This is an x squared, this is an x, so I can't put them together. So that is finished. Okay, now the next thing we're going to do is we're going to look at what we call the distributive law, and that's going to be the second part of this video.